Dear students, welcome to second PU physics class. In this class, let us start new chapter, electrostatic potential and capacitance. So before going to define the electrostatic potential, first let us discuss about the potential energy of the charge. Okay? We know the potential energy of the body is the energy possessed by the body by virtue of its position. Okay? Right. Similarly, if you consider a source charge Q is placed at any point in the region of the space, then the electric field is created around this source charge. Okay? Here, at every point it possesses certain potential energy. Okay? Right? Here, when the source charge is placed in the region of space, then the electric field is created around this charge. And also, here, every point in this electrostatic field possesses certain potential energy. Okay? So, potential energy of the charge at any point in electric field so it is work done in moving a charge from infinity to that point, so against the electrostatic repulsion. Okay, means suppose we have to calculate the potential energy at this point P, okay, in this region of space. Then we will imagine to be here the charge is situated at infinity. Okay, then while bringing the charge from infinity to point P, there will be the force of repulsion. Okay, because here around point P, the electrostatic field is there. So while bringing this unit positive charge from infinity to point P, here the work is to be done. Okay, work is to be done against here the electrostatic force. Okay, right. Hence here the potential energy of charge at any point in electric field is defined as it is work done in bringing a unit positive charge from infinity to that point against the electrostatic force of repulsion without any acceleration. Okay, right. So now come to the topic, that is electrostatic potential. At any point in electric field. Okay, it is denoted by capital V. Okay, right. So now here potential energy of the charge ಅನ್ನು ಡಿಫೈನ್ ಮಾಡಿದ್ದೇವೆ. Similarly, electrostatic potential ಅನ್ನು ಕೂಡ ಡಿಫೈನ್ ಮಾಡಬಹುದು. Okay, so again consider the same picture. This is Q and this is infinity. Here the unit positive charge. Okay, ಹೀಗಾಗಿ ಇಲ್ಲೂ ಕೂಡ ಸೊ ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಅಂದ್ರೆ it is work done in bringing a unit positive charge from infinity to point P against the electrostatic force of repulsion without any acceleration. Okay, right. So write down the definition here. It is work done in bringing a unit positive charge from infinity to that point against electrostatic force of repulsion without any acceleration. Okay, without any acceleration. This definition is important. Okay, ಇಲ್ಲಿ force of repulsion ಅಂತ ಯಾಕೆ ಬಂದಿದೆ? ಸೊ ಸೋರ್ಸ್ ಚಾರ್ಜ್ ನಾವು ಜನರಲಿ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಅನ್ನೇ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೇವೆ. ಓಕೆ, ಇದರ ಸುತ್ತ ಏನಾಗುತ್ತೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಕ್ರಿಯೇಟ್ ಆಗುತ್ತೆ. ಓಕೆ, ಈ ಡೆಫಿನೇಷನ್ ಪ್ರಕಾರ ನಾವೇನ್ ಮಾಡ್ತೀವಿ, ಇಮ್ಯಾಜಿನ್ ಟು ಬಿ ಇನ್ಫಿನಿಟಿಯಿಂದ ಒಂದು ಯೂನಿಟ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಅಥವಾ ಟೆಸ್ಟ್ ಚಾರ್ಜ್ ಅಂತ ಕರಿಬಹುದು ನೀವು. ಒಂದು ಯೂನಿಟ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಅನ್ನ ಏನ್ ಮಾಡ್ತೀವಿ, ಇನ್ಫಿನಿಟಿಯಿಂದ ಇಲ್ಲಿ ಸೊ ಈ ರೀಜನ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇಂದ ಒಂದು ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಆ ಚಾರ್ಜ್ ಅನ್ನು ಏನ್ ಮಾಡ್ತಾ ಇದ್ವಿ, ಬ್ರೇಕ್ ಮಾಡ್ತಾ ಇದ್ವಿ. ಓಕೆ, ಹೀಗಾಗಿ ಇಲ್ಲಿ ಎರಡು ಕೂಡ ಏನು ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್. ಹೀಗಾಗಿ ಈ ಎರಡು ಚಾರ್ಜ್ ಗಳ ನಡುವೆ ಫೋರ್ಸ್ ಆಫ್ ರಿಪಲ್ಷನ್ ಇರುತ್ತೆ. ಆಸ್ ಯು ನೋ, ದ ಅನ್ಲೈಕ್ ಚಾರ್ಜಸ್ ಅಟ್ರಾಕ್ಟ್ ಈಚ್ ಅದರ್ ಅಂಡ್ ಲೈಕ್ ಚಾರ್ಜಸ್ ರಿಪೆಲ್ ಈಚ್ ಅದರ್. ಅದಕ್ಕೆ ಇಲ್ಲಿ ಯಾವ ವರ್ಡ್ ಬಂದಿದೆ, ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ ಫೋರ್ಸ್ ಆಫ್ ರಿಪಲ್ಷನ್ ಅಂತ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಓಕೆ, ರೈಟ್. ನೆಕ್ಸ್ಟ್, ಸೊ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ expression, this electrostatic potential V equal to work done by charge. Okay, work done by charge equal to work done is denoted by capital W and charge is denoted by Q. Okay, now discuss some points regarding this electrostatic potential. Okay, first one, it is scalar quantity because we know the work done is also scalar and electric charge is also scalar, hence electrostatic potential is scalar quantity. Next, here the SI unit of electrostatic potential is V equal to again W by Q equal to, here the SI unit of work done is joule and that of electric charge is coulomb equal to joule per coulomb. Okay, joule per coulomb is called as volt, is denoted by capital V. Okay, next, the directional formula V equal to again W by Q equal to direction formula of the work done is m raised to 1, l raised to 2 and t raised to minus 2 divided by, for electric charge it is 80. Okay, which is equal to, on simplification, we will get n raised to 1, l raised to 2, t raised to minus 3 and a raised to minus 1. So this is the dilution formula of electrostatic potential. Okay, electrostatic potential. Right. Now we can define 1 volt. Next is definition of 1 volt. Okay. So how will you define 1 volt? 1 volt equal to 1 coulomb by 1 joule by 1 coulomb. Okay. 1 volt equal to 1 joule by 1 coulomb. Hence, it can be defined as, here the electrostatic potential is said to be 1 volt if is said to be 1 volt if here 1 joule of work is done in bringing, okay, how much work done? That is 1 joule of work is done in bringing, here how much of charge? 1 coulomb of unit positive charge. One coulomb of unit positive charge from infinity to that point, against electrostatic force. Against electrostatic force. This definition is important. Okay, so remember this is definition of electrostatic potential, then properties of this electrostatic potential, next definition of 1 volt. Okay. Next. Electrostatic potential the next topic is electrostatic potential difference between 2 points. Electrostatic potential difference between 2 points. Okay, it is also known as voltage. Okay. For this, consider a diagram. VA and VB. Okay, right. So in this diagram, VA and VB are potentials at point A and B respectively. Okay. Then here the potential difference between A and B can be written as A and B can be written as VAB equal to VB minus VA. Okay, VAB equal to VB minus VA. Right? Okay. Again here, the definition potential is as follows. It is the work done by external force. So in bringing a unit positive charge from one point to another point. Okay, right? Here the electrostatic potential difference between 2 points is defined as it is work done in carrying a unit positive charge from one point to the another point against the electrostatic force without any acceleration. Okay, right. Again, the properties are same as follows. It is the electrostatic potential is scalar. Next, SI unit is volt, and dimension formula is same as that of electrostatic potential. Okay. Now, here the electrostatic force is conservative. Conservative means what? In same diagram, if you consider the two paths, one is A to B and another one is B to A. Okay. Now consider the total work done, or here the potential difference between these 2 points VAB equal to when a charge is here. So when a net positive charge is moved from point A to point B, then potential difference VAB equal to VB minus VA. Okay. Similar way, when an electric charge is moved from point B to point A, then VBA equal to VA minus VB. Okay. Now the total work done over closed path AB, over a closed path AB equal to VAB plus VBA equal to VB minus VA plus VA minus VB. Here these terms are getting cancelled, is equal to 0. Means here the total work done over a closed path is equal to 0 represents electrostatic force is conservative in nature. Okay. Next, the important derivation is electrostatic potential at any point due to point charge or source charge. Okay, it is important for finding, right? Okay. So for this, consider a diagram. Point O or origin in which the charge Q is placed. Okay, here charge Q, here the charge plus Q is source charge. So consider this diagram, right? Okay. Here at origin the source charge plus q is placed. Okay. Then the direction of electrostatic force is shown as capital F. Okay. Right. Next here, the point P is situated at a distance r from the origin O. Okay. Next, here A is the intermediate point which is at a distance x from the origin O. Okay. Right. So, in derivation alli now electrostatic potential ಗೆ expression ಅನ್ನು find out ಮಾಡಬೇಕು. Okay. ಹೀಗಾಗಿ ನಮಗೆ ಆ expression ಅನ್ನು find out ಮಾಡಲಿಕ್ಕೆ we know it is work done by charge. ಹೌದಾ? electrostatic potential ಅಂದ್ರೆ work done by charge. So, ನಮಗೆ work done value ಬೇಕು ಅಂದ್ರೆ we have to calculate force into displacement. Okay. ಹೀಗಾಗಿ ಫಸ್ಟ್ ನಾವು ಈ ಡಿರೈವೇಶನ್ ಅಲ್ಲಿ electrostatic force at point A ಅದನ್ನ ಫಸ್ಟ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡೋಣ. ಓಕೆ. ಹೀಗಾಗಿ magnitude of electrostatic force at A. Okay. Applying Coulomb's law, F equal to 1 by 4 pi epsilon naught into ಇಲ್ಲಿ ನಾವು ಪಾಯಿಂಟ್ ಎ ನಲ್ಲಿ ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ ಫೋರ್ಸ್ ಅನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತಾ ಇದ್ದೇವೆ. ಇಮ್ಯಾಜಿನ್ ಟು ಬಿ ಇಲ್ಲಿ ಒಂದು ಟೆಸ್ಟ್ ಚಾರ್ಜ್ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ, ಇಟ್ ಈಸ್ ಯೂನಿಟ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇದೆ. ಓಕೆ, ಯೂನಿಟ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇದೆ, ರೈಟ್? ಹೀಗಾಗಿ ಸೊ ಕೂಲಂಬ್ ಫೋರ್ಸ್ ಈಸ್ ಪ್ರಪೋರ್ಷನಲ್ ಟು ಪ್ರಾಡಕ್ಟ್ ಆಫ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆಫ್ ಚಾರ್ಜಸ್. ಓಕೆ, ಹೀಗಾಗಿ Q into magnitude of UPC, that is unit positive charge, is 1 divided by square of distance between these two charges. ಎಷ್ಟು distance? x. ಹೀಗಾಗಿ x square. Okay, so which is equal to 1 by 4 pi epsilon naught into Q divided by x square. Okay, Q divided by x square, which is acting along which direction? Yes, along which direction? OP. Okay, along OP. It is acting along OP. Now force value ಸಿಕ್ಕಿದೆ, ಹೌದಾ? ನಾವೀಗ ವರ್ಕ್ ಡನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ವರ್ಕ್ ಡನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಿದ್ರೆ ಜಸ್ಟ್ ಇಮ್ಯಾಜಿನ್ ಮಾಡಿ, ನೀವು ಪಾಯಿಂಟ್ ಎ ದಿಂದ ಪಾಯಿಂಟ್ ಬಿ ಗೆ ಒಂದು ಯೂನಿಟ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಅನ್ನು ನೀವು ಮೂವ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ. ಓಕೆ, ಥ್ರೂ ಡಿಸ್ಟೆನ್ಸ್ dx. ಓಕೆ, ಹೀಗಾಗಿ small work done, small work is done in moving unit positive charge from A to B through distance dx. From A to B through distance dx. Okay, it is dw equal to, so what is the expression? Work done ಗೆ force into displacement. Force is really at point A ದಲ್ಲಿ. So what is the value of electrostatic force? It is F. F into distance is dx. Okay, so ನಾನು ಇಲ್ಲಿ ವೆಕ್ಟರ್ ನೋಟೇಷನ್ ಅನ್ನು ತಗೊಳ್ತೇನೆ. ಹೀಗಾಗಿ I will write dw is equal to scalar product of force into displacement. Okay, which is equal to F dx into cos theta. Will you agree? Okay, where theta is angle between, yes, force and displacement. Okay, which is equal to F dx into, ಇಲ್ಲಿ ಆಂಗಲ್ ಎಷ್ಟಾಗುತ್ತೆ? ಫೋರ್ಸ್ ಎರಡು ಕೂಡ ಒಂದೇ ಲೈನ್ ಅಲ್ಲಿ ಆಕ್ಟ್ ಆಗ್ತಾ ಇದೆ, ಹೌದಾ? ಆದ್ರೆ ಅಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್. ಹೀಗಾಗಿ ಆಂಗಲ್ ಬಿಟ್ವೀನ್ ದೀಸ್ ಟು ವೆಕ್ಟರ್ ಈಸ್ ಈಕ್ವಲ್ ಟು 180 degree. Okay, so 180 degree, which is equal to cos 180 degree equal to minus 1. Yes, ಹೀಗಾಗಿ minus f into dx. ಈಗ ಇಲ್ಲಿ f ವ್ಯಾಲ್ಯೂನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ minus into 1 by 4 pi epsilon naught into q by x square into dx. Okay, now ಇಲ್ಲಿ ಫೈಂಡ್ ಮಾಡಬಹುದು ಇಟ್ ಇಸ್ ದಿ ಸ್ಮಾಲ್ ವರ್ಕ್ ಡನ್. ಹೌದಾ? ಸೊ ನಾವೇನ್ ಮಾಡಬೇಕು, ಇಲ್ಲಿ ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ನ ಡಿರೈವ್ ಮಾಡಬೇಕು. ಅಂದ್ರೆ ಸೊ ಇನ್ಫಿನಿಟಿ ಇಂದ ಪಾಯಿಂಟ್ ಪಿ ಗೆ ನೀವು ಒಂದು ಯೂನಿಟ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಅನ್ನ ತಂದಾಗ ಅಲ್ಲಿ ಆಗಿರುವಂತಹ ವರ್ಕ್ ಡನ್ ಅನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಓಕೆ, ಹೀಗಾಗಿ ಟೋಟಲ್ ವರ್ಕ್ ಡನ್ in bringing unit positive charge from infinity to point P. Okay, point P ಯಾಕೆ ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕು? Here P is a point, so it is situated in the electrostatic field of plus Q. Okay, right. ಈಗ ನೀವು ಟೋಟಲ್ ವರ್ಕ್ ಡನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಯು ಹ್ಯಾವ್ ಟು ಇಂಟಿಗ್ರೇಟ್ ದಿಸ್ ಈಕ್ವೇಷನ್, ದಟ್ ಈಸ್ ಇಂಟಿಗ್ರೇಷನ್ ಆಫ್ dw. ಇದಕ್ಕೆ ನೀವು ಲಿಮಿಟ್ಸ್ ಅನ್ನು ಅಪ್ಲೈ ಮಾಡಬೇಕು. ಫ್ರಮ್ ವೇರ್ ಟು ವೇರ್? ಫ್ರಮ್ ಇನ್ಫಿನಿಟಿ ಟು r. ಹೀಗಾಗಿ ಫ್ರಮ್ ಇನ್ಫಿನಿಟಿ, ಲೋವರ್ ಲಿಮಿಟ್ ಇನ್ಫಿನಿಟಿ ಟು r. r ಯಾಕೆ? ಬಿಕಾಸ್ ಪಾಯಿಂಟ್ P ಗೆ ತರಬೇಕು ಅಂದ್ರೆ ಪಾಯಿಂಟ್ P ಸೋರ್ಸ್ ಚಾರ್ಜ್ ಇಂದ ಎಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್ ಇದೆ? r. ಹೌದಾ? r ಡಿಸ್ಟೆನ್ಸ್ ಅಲ್ಲಿ ಇದೆ. Now substitute value here, that is integration of w equal to infinity to r dw is equal to integration of dw expression I bari minus 1 by 4 pi epsilon naught into q by x square into dx, which is equal to ಇಲ್ಲಿ ನೆಗೆಟಿವ್ ಸೈನ್ ಅನ್ನ ಇಂಟಿಗ್ರೇಷನ್ ನ ಹೊರಗಡೆ ಬರೀರಿ, ಜೊತೆಗೆ ಈ ಟರ್ಮ್ ಕೂಡ ಏನು ಕಾನ್ಸ್ಟೆಂಟ್. ದಿಸ್ ಟರ್ಮ್ ಇಸ್ ಆಲ್ಸೋ ಕಾನ್ಸ್ಟೆಂಟ್, ದಿಸ್ ಟರ್ಮ್ ಇಸ್ ಆಲ್ಸೋ ಕಾನ್ಸ್ಟೆಂಟ್. ಹೀಗಾಗಿ q ಡಿವೈಡೆಡ್ ಬೈ 4 pi epsilon naught into integration of 1 by x square into dx from limits infinity to r. ಈಗ ಅದನ್ನ ಇಂಟಿಗ್ರೇಟ್ ಮಾಡಿದಾಗ q by 4 pi epsilon naught. Yes, what is the integration of 1 by x square? ಗೊತ್ತಿದೆ ಅಲ್ವಾ? that is x raised to minus 2 ಅಂತ ತಗೊಂಡ್ರೆ ನೀವು ಇದರ ಫಾರ್ಮುಲಾ ಬರುತ್ತೆ 1 by x minus 1 by x. ಕರೆಕ್ಟಾ? ಸೊ ಈಗ ಇದಕ್ಕೆ ಲಿಮಿಟ್ಸ್ ಅನ್ನು ಅಪ್ಲೈ ಮಾಡಬೇಕು. x equal to infinity to x equal to r. x equal to infinity to x equal to r. Okay, ಈಗ ಇದರಲ್ಲಿ ಲಿಮಿಟ್ಸ್ ಅನ್ನು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ 1 by 4 pi epsilon naught into first upper limit value minus 1 by r minus 1 by infinity. ಕರೆಕ್ಟಾ? ಓಕೆ, ಸೊ ಮೈನಸ್ ಆಫ್ ಮೈನಸ್ ಆಗುತ್ತದೆ. ಸೊ ವಿಚ್ ಇಸ್ ಈಕ್ವಲ್ ಟು minus q divided by 4 pi epsilon naught into minus 1 by r. As you know, 1 by infinity is 0. So which is equal to minus in multiply ಮಾಡಿದಾಗ plus ಆಯಿತು q by 4 pi epsilon naught r. ಹೀಗಾಗಿ what is the expression here? w equal to 1 by 4 pi epsilon naught into q divided by r. ಇದು ವರ್ಕ್ ಡನ್ ಗೆ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಆಯಿತು. ಹೀಗಾಗಿ ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಅಂದ್ರೇನು? ದಟ್ ಈಸ್ V equal to W by Q. ಇಲ್ಲಿ Q ಇರೋದು ಯೂನಿಟ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್, ಅದರ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ 1. ಹೀಗಾಗಿ ಸೇಮ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಬರೀತೇವೆ V equal to 1 by 4 pi epsilon naught Q divided by R. So this is expression for the electrostatic potential at any point due to point charge अथवा source charge. Okay. Okay. Dear students, welcome to second PU physics class. In last class, we studied about electrostatic potential at a point due to point charge. Okay. The expression is as follows: V equal to 1 by 4 pi epsilon naught Q divided by R. Okay. Here Q is the point charge or source charge, and here P is the point of observation. Here distance between source charge and point P is R. Then the electrostatic potential at the point P due to source charge plus Q is given by this expression. Okay. Here V is proportional to 1 by R. Okay. If you draw the graph of electrostatic potential versus the distance between point of observation and source charge, then graph nature is like this. It is exponential curve. Okay, because V is proportional to 1 by R. Hence, we are getting the exponential curve. From this graph, if R equal to infinity, then V equal to 0. Okay, V equal to 0 means here when the distance between point of observation and source charge is small, then potential will be greater value. Okay, right? And also you can conclude from this expression, if Q is positive, source charge is positive, then electrostatic potential is also positive. Okay. If suppose the source charge is negative, then potential is also negative. Okay. Because it is depends on the source charge Q.